Okay, this is the video to assist with homework for assignment 10.2. So this is the one where we're looking at linear inequalities. I'm looking at systems of linear inequalities specifically. So for our first question, we're asked to ask whether certain points meet the criteria. On your questions, there's only one, but I've added in 4 just so we can see what happens. So basically just type in the question, whatever it is, and then look at the picture. So we're not just looking for any part that's shaded like we did in 10.1. When we're looking at a system, we're looking for the part that's the darkest part of the shading. So in other words, we're looking in this region here. So if I just switch one off, notice what we're looking at is this is the whole area for the first region. And then this is the whole region for the second one. So we're looking where they intersect. So we're looking basically at this part here. Now I've labeled the points as well. Let me just click on the, sorry, I put in the coordinates. Let me label them so you can see them. So the first one, 2, 4. So although it's in the shaded part, it's not in the correct shaded part. So 2, 4 would not be a solution. Whereas the point 4, 2, you can clearly see is definitely within this region. So you would count that one as a yes. Now 2, 0 is on the line, and this is the one where we have to make a decision, will it count or not? So we will count it if it has an equal sign with it. So the one that's actually graphed for this line here, that's actually this one here. So we can tell it's this one here. Obviously, the dotted one is the other one. So for this one here, as it's a solid line, that's the one which we do include. So 2, 0 would be a point that we would count. Now, 0, -1, I put on here. It's on the dotted line, but you can actually clearly see it's not with anywhere near this region at all. So this would be one that I would not count at all right now. Now, if I change it, though, to, let me change it to 2, 3, which would probably be a better question. There. So right now, it is lying on this line of this region that's shaded. So for this one, we do not count it. The ones that lie on the dotted line, we do not count. But the ones on the solid line, we do count. So for this question, the one that I would count is this one, because it's clearly inside the region, and this one, because it's on the edge of the region, and it's a solid line. And I didn't include this one because it was on the solid, it was on the dotted line on the edge of the region. So 8, 9, and 10 are going to be similar. Type in the two equations, two inequalities, and then just type in the 1 point and just look to see which region it goes for. But you're looking for the region that's the darkest to make that decision. This one asks you to graph a system. So as you're actually in Desmos, it kind of makes sense that you would actually just type in the question. So look at a few of the properties for this one. The ones that will have just y by themselves, as in no x's for this one, this is that word hoy that we looked at in earlier units. This is horizontal lines. You can see it goes through -1 on the axis. I'm just going to zoom in so you can see that a little clearer. There you go, -1. And notice there's no equal sign, which is why we have the dotted line here. And less than for this one will just be below the line. And for this one, second one, y minus 2x is, that's supposed to be greater than or equal to. As you type it in like that, it will actually give you the proper symbol. 5. And that would enable us to actually draw the picture. So normally on SOL, it'll ask you to click 2 points. So you'd click like here, and then it will draw the line for you. And then you can toggle whether you want it solid or dotted. And then you can click on the region whether you wanted it shaded or not. Now I'm going to zoom back out again because there's actually a few other things. So for this one here, what I would actually need to do is I would need 2 points that I can see that lie on this line here. So I would always stop at the intercept. So certainly 5 is 1 point that lies on this line. And I can see this point here as well, which is 1, 7 also lies on the line as well. There we go. We can just about see the 1 there. There we go. 1, 7. And then same thing. Once you've clicked on it, then you can see exactly where. Now, for questions like this, normally they would ask you which of the 4 segments. Is it this one, this part here, or this part here? So clearly for this one, you can see that you would select this one down here. 18 is pretty similar. It's just that the question is written in a different format, but that doesn't make any difference to us. We're just going to go ahead and, type it in correctly for starters. We're just going to type it into Desmos, just like we did for the other one. And then we're going to look for which is the relevant part for this one. So let me just make sure I got that correct. Yeah, there we go. That looks all right. 3x minus y. There we go. That looks much better. So we're going to make sure that we get these two graphs the same. So one thing that's often helpful is if they have, look at the intercepts. If they're whole numbers, then you can certainly pick these ones. So -3 and -3, you can click on those 2 points and you can draw that one up. Notice both of these actually don't have an equal sign. So that's why we actually have two dotted lines this time as well. And just happens that we have two greater than symbols on this one as well. So they don't have to be different, but often they will be. For this one over here, I can certainly see it goes through -2 on the x-axis, and I can see it goes through 6 on the y-axis. So I could use that to help me as well. If that didn't help me on this, then I could always look for another point. So here I can see the point 19 also lies on the line. And then you can click on the 2, and then you can obviously draw the graph. And then clearly we're looking for the darkest of the three colors here. So obviously these two are fairly light. So you would select this region here. For 23 and 24, it's the reverse. They've actually drawn the picture for us. And this time we've got to figure out what the equation is. So probably the easiest way to do this is slope-intercept form. So look where it goes to on the y-axis. So for this one here, I'm just going to put equals to begin with. I can see that it goes through 5, and I can see the slope here. It goes down 1 and then across 3 squares. So I got -1/3 x, and then it went through 5 on the axis. And it looks like it drew that line in for me pretty good there. So that's not too bad. I'm just going to switch it off for a second. It is a solid line, and I can see that it's shaded below here. So I'm actually going to change this into a less than and equal to. And we're just going to leave that just for a second to see how that turns out. And then for the other one, let's see what we got here. This goes through -1. So also I can see it's shaded above this line, and I can see that it's a dotted line. So I'm just going to leave this one as greater. I'm going to put -1. Whoops. And then for the slope for this one, I can see that it goes up 2 and across 1. So I know that's a slope of 2. And that's what I think is the correct answer for this one here. Now, I actually have the answers typed in at the bottom here. That's actually how I drew the picture. So let's just check to see how that looks. Y is greater than 2x minus 1. There we go, we got that one. Y is less than or equal to -1/3 x plus 5. There we go. Now, you normally do this on a blank screen, and you just look at the picture and try and match it up. But that's certainly one way you can do to try and check those ones. So 23 and 24 are going to be very similar. Pay attention to the dotted line and the solid lines. Pay attention to whether it's under the line or above the line as well. And if necessary, you can always change the picture. If it doesn't quite match it, then just go ahead and change it until it does match what you're actually looking for. So if I put the wrong symbol here, you can suddenly see it shaded a totally different area that I didn't want there. So you can quickly change it back if you need to. And for the last question, we've got a word problem. You can spend at most $200 on clothes. Jeans cost $54.99 and t-shirts cost $29.99. You need to buy at least 3 pieces of clothing. So most amount of money we can spend, obviously $200, and we've got to buy at least 3 things. So I'm going to use X and Y, X for jeans and Y for t-shirts. If you use J and T, the first letters, it's only going to say error anyway. So X is going to be my price for jeans, and Y is for t-shirts. So each pair of jeans is $54.99, so $54.99X. Each pair of t-shirts is $29.99, so $29.99Y. And we need that to be less than or equal to, because we only have $200. And also that word at most also means less than or equal to 200. So notice these are all monetary amounts. Money amount, money amount, money amount. The total amount of jeans and the total amount of t-shirts must be at least 3. Now that actually means the opposite. That means greater than or equal to. So I can buy 4 if I want to, or if I can afford 4. But certainly I've got to have at least 3. So X plus Y is greater than 3. And then it draws this picture for us. Once again, we're looking for the darkest region. So we're looking in this region here. And some of these points you can see actually fit on the line here. So 0, 3, the second letter was Y. So you can certainly buy 3 t-shirts. And you could probably see that 3 t-shirts is definitely under $200. You could buy 4 t-shirts, 0, 4, 0, 5, and 0, 6. So 6 t-shirts as well would be an answer for this question. Looks like on here, let's have a look. Oops, didn't quite get it. I think 1, 2 is one of the points on this line. There we go, 1, 2. So you can also buy 1 pair of jeans and 2 pairs of t-shirts, 1 pair of jeans and 3 t-shirts, 1 pair of jeans and 4 t-shirts. I notice you can't buy 1 pair of jeans and 5 t-shirts because that'll be outside the region. I could also buy 2 pairs of jeans and 1 t-shirt, 2 pairs of jeans and 2 t-shirts, and it looks like it's right on the line there as well. Just a bit over 3.002. So yeah, we can definitely buy 2 jeans and 3 pairs of t-shirts as well. And then as we look in here, I can see 3 pairs of jeans and no t-shirts, and 3 pairs of jeans and 1 t-shirt. And we're going to ignore this region because notice these are negative values. And that's the same reason I ignored this as well. You can't buy a negative pair of jeans or a negative pair of t-shirts. This question just asks you to write and graph, but sometimes they'll ask you to check a solution as well, which is why I included just a little bit more information. All right, hopefully that should help you to go and finish that homework exercise.